When we study matrices, one of the most useful concepts in study of matrices is the determinant. So we're going to take a look now at determinants. Let's suppose we have a matrix. Now this is a 2 by 2. We're going to look at finding determinants for 2 by 2s and then 3 by 3s. And you could generalize and then find matrices for 4 by 4s and so forth. But if you're looking at a 2 by 2 matrix, the way you find the determinant, now the determinant, there's a couple of ways we notate it. We have DET with little parentheses A, or we have a little absolute value type thing here. We would put the A in. Both of these mean determinant if you're talking about matrices. And the way we calculate the determinant is we multiply the numbers on the main diagonal. If this is a 2 by 2. So 2 times 6 minus 4 times 5. So we go 2 times 6 minus 4 times 5. So this is going to be 12 minus 20, and we get negative 8. So that's how we calculate that. Now, you have to be a little careful when you're doing this, of course, when you have negatives pop up, like in this matrix. So if we want this determinant, notice what we're going to do. We're going to say 3 times 6 minus, we put that minus there and then say 2 times negative 5. See, we go ahead and put the minus there. We don't want to mess up. It's easy to mess up on the signs. And that's just going to be 18 plus 10, which is going to be 28. Okay, now let's look at determinants for a 3 by 3. So here we have a 3 by 3 matrix. Now this is going to be a little more work intensive, but here's what I'm going to do. I'm going to rewrite this matrix 3 times. And here's the process for finding the determinant. I'm going to work with row 1. You could work with any row or any column, but I'm going to pick row 1, and I'm going to use that as my row to build the determinant. Now, I'll show you what I'm talking about. For this row 1, the first number in row 1 is this 2. Now, I'm going to circle this 2 and eliminate everything to the right of it and everything below it. In other words, that entire row and that entire column where the 2 is. Now notice what I have here. I have the 2 and I have a little 2 by 2 over here, a little 2 by 2 matrix. So here's what I'm doing now. Now notice this. This 2 is in position 1, 1. It's in row 1, column 1. So what I'm going to do is I'm going to make this calculation. I'm going to take negative 1 to the row 1, column 1 power. In other words, I take the row 1, column 1. Since it's 1, 1, I have negative 1 to the 1 plus 1. This is always what you're going to do for each one of these terms. You're going to, because the signs are going to alternate. And the way the signs alternate is consistent with this little technique here. Raise negative 1 to an either even power or an odd power. And if you raise a negative 1 to an even power, you get a positive. If you raise it to an odd power, you get a negative. So what we do is we put the row 1, column 1, so there's 1 plus 1. Now, times the little pivot here, the 2. See? And then times the determinant of what's left, 6, 7, 3, 9. 6, 7, 3, 9. Okay. Now, I'm working with row 1. If I were working with column 1, my next pivot would be this 4. But I'm working with row 1, so I'm going to the next number, which is 5. Okay, I forgot. I'm going to go ahead and do this part here. Okay, so there we have, notice the negative 1 to the second power, that's just 1. So we're left with 2, and then here's my determinant down here, 6 times 9 minus 7, 3 times 7. Now here's my next pivot. Okay, so I'm going to take out everything to the left and right and everything below. Now notice that this is position 1, 2, row 1, column 2. So it's going to be negative 1 to the third power. See? There it is. So notice I put a plus sign there. So in calculating our determinant, we're going to have this first calculation plus the second calculation. Now let's see what this is going to give us. This is going to give us, this is a negative number now, so we have a negative 5 times 4 times 9 minus 1 times 7. There we have it. Okay. Now our next pivot is 3. Notice we're just going right across the top here. Okay, so I'm going to take out everything in the row and the column where that 3 is. And now notice this is row 1, column 3. So it's going to be negative 1 to the 1 plus 3 power. See that? Times the pivot, and then times this determinant, 4, 6, 1, 3. You see where these numbers come from? Like over here, it's 4, 7, 1, 9. See? Then we calculate this. This is negative 1 to the 4th power. Well, that's just positive, so we just get the 3 times 4 times 3 minus 1 times 6. Now, these 3 terms are going to make up the determinant when we combine them. So let's see what we have here. For this first term, we have 2 times 33. This right here is just going to be 33. Now for the second term, this one, negative 5 times 29. This is just 29. And then we have the third term, 3 times 6. This right here is 6. And when we combine all of these, add all of these up, we get negative 61. This is our determinant. So we say the determinant of this matrix is negative 61. So it's a little bit of work. Now, let's look at another example with, so I modified matrix A a little bit. Notice I put zeros over here so that this is a lower triangular matrix. Now this would work, what I'm going to show you here would work if it were an upper triangular matrix as well. But the fact is we've got zeros above the main diagonal. Only 0. So you've got the main diagonal and then everything above that is, every entry is a 0. Now let's find the determinant. Okay, same way. I'm going to make 3 matrices and I'm going to go across using the row. So I've got my 2. Take out everything on that row and that column, and here's what I get. Just like before. And notice we have 2 times 6 times 9 minus 3 times 0 right there. Okay, then we go to the next one. Here's 0. Well, take out everything in that row and that column, and now look what we have. Negative 1 to the 1 plus 2 times 0. Well, this whole term's going to go out. But let's go ahead and play along for a minute. This is what we've got. Then I look at the next one. It's 0 also. The pivot is 0. Take out the row and the column, just like before, but now we have 0 here. Now notice, this term and this term they're just 0. So we don't even need to mess with them because we're multiplying by 0. However, this one makes a difference. Now look at this. 3 times 0, that's 0. So really, this determinant is just 2 times 6 times 9. Right there. That's the determinant. Now notice what that is up here. That's the product of the elements on the main diagonal. The entries on the main diagonal. It's just the product. 2 times 6 times 9. Now this is going to always work out this way. If you've got an upper or lower triangular matrix, it doesn't matter how big the matrix is. It could be 100 by 100. If you want to get the determinant, just find the product of the elements on the main diagonal. And in this case, the determinant is 108. Now let's take a look at how we would use our calculator to find the determinant. And really, you're going to want to use your calculator most of the time, especially whenever you have a big matrix, maybe a 4 by 4, 6 by 6, something like that. You're going to want to use your calculator. But we need to know this technique, how one finds the determinant, because in certain types of problems where we use this method, the calculator is not going to be available to us. So anyway, let's look at this. What I want to do is I want to put the matrix that we just looked at in our calculator. Okay, So here we go. I just went ahead and put that matrix in our calculator, and this is it. I went ahead and did that ahead of time. Okay, now I'm going to do second quit, go to the home screen, and here's how we find the determinant. Second matrix, go over to math, and it's the very first thing up there. And then I do second matrix, A. And I don't have to close the parentheses, but I will for good form. And then enter. There it is, negative 61. So that's how we can use our calculator to find these determinants.